Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And this is the series where we are creating a programming language from scratch. The programming language is named Tang, which is up there. Stands for template language, and we are using our bare C++, hopefully modernish C++ skills. A terminal window, Vim is our editor, and Flex, Bison, Google Test, ICU are our tools. And if you saw the previous episode, you might notice I'm in the same shirt. Why? Because it's Christmas Eve. And I may not be able to record a video tomorrow. Tomorrow is Christmas Day, but it's also a Sunday. And that means church and then traveling to meet up with family. And so I may not get a video out, and I'm trying to do a video a day. And I don't want to fall behind in my recording, even though, let's face it, nobody's watching this live. I know that. You know that because you're watching this after the fact. But I'm still trying to get this done. All right, so where are we? Well, I've said at every episode, I've got nothing up my sleeves. Excuse me, nothing is pre-prepared except for today. And what happened is, well, let's just go to the code and go ahead and make clean, make test, go ahead and get this started. And what I've done is I started going through, first of all, if I say get diff or get status, there's changes all over the place. And you notice they're all in these AST nodes and, well, a few other places as well. Is this sometimes in CPP files, sometimes in HPP? It's like, what is going on? Well, I started down a rabbit hole. I thought I'm going to clean up some stuff, and we already know this, that sometimes when I make a change, the make file doesn't pick up on everything because I don't have all my dependencies listed very well. And I thought, I'm going to try to fix this up a little bit. So, get diff, not q, wait, if I show you get log, you'll see the very last commit was the end of episode 73. So these changes that are live are the only ones that I've done. And now if I say get diff on the make file, just the make file, you see I took this big ugly thing and transformed it into I know that this is because it's using tabs. But they're all, the question is should I, no, I'm just going to leave it like this. I put them all in alphabetical order and put them all in their own line. That's what I did. So if I vim make file, that's what we see now. Lib objects, and we can, it's just, it'll make it easier in the future, even though there's probably not going to be a lot more added to it. Well, there might be. But, yeah. So that's the first change. It didn't change any code. It was just, fixing the formatting. So, and that's the only difference in the make file. So I'm going to get commit make file. Oh, I forgot, didn't do my message. What is my message? I tried to hit I to insert this. What did I do? I reorganized object file list for easier navigation and editing. Okay. It is not that. It's control. Is it O to write out? Yep. And now X. There we go. That is our get log reorganized object file list for easier navigating. Okay, I should have put it just in line, but okay. there's that. Now, there's still all of these changes. What are they? Well, it starts with, this is our documentation. And I just decided, I looked at astnode.hpp, and I know I've got this circular reference. And so, well, let's open it. Include astnode.hpp, and I was including program.hpp. All right. So I realized the only place I was using it was, first of all, pass by C++ pass by reference. Here's another one, pass by reference, and that's it. So that means I don't have to include program because I don't need the entire header. I just need the declaration, the prototype, forward declaration of program, because I don't need anything else. So I took it out so that I won't have this circular reference. And now I want to try this right in front of you. If I say make docs, docs-pdf. I know this is running. You can probably hear my computer. And reload this. That greatly simplified the dependency graph. Greatly simplified it. Okay, and then I can still see what all is including this file, and there's a lot. But yeah, but when I removed it, then I had a lot of files where I needed to add back in program.hpp. And not only that, or no, let's just do this. Git diff source, and let's look at one of these. Well, source astnode.cpp. Okay, for this I just had to include the program. There are some that are diff. Let's look at include astnode.hpp. No, I just removed it. Okay. You're saying, Corey, what are you getting at? This is source and include. Okay, this is all the differences. You notice though some of the differences, like in this .hpp file, are that I had to add std in front of shared pointer. And you may remember me saying in a recent episode, no, it happened twice, that I was editing something in a header and I'm like, why didn't I have to include standard, the std : that meant that someone somewhere was doing a using namespace standard in a header file, and that's a no-no. Well, I found it. So if we look through, all of these changes are either the standard thing or the as that's what these are. That's what this is. I at std : we'll go down. That's what all those are. Same there. Same there. There. Keep going, and I'm looking for one where it's different. Oh yeah, in some cases it's the std : string. There, right there. Singleton object pool.hpp. I had put a using namespace standard, and I know that was only there for debugging or just temporary purposes. Why? Because I would not have put it in without a space before the word using. That's just the way my coding style, and that was a mistake that it got included. And so then anything that included singleton object pool.hpp was in the standard namespace, and I very much regret that happening. But okay, so fixing that meant that we had to first of all add std : for all of these shared pointers and strings that no longer are using the namespace standard by default. So anyway, and then I had to add the #include program.hpp in these individual files. So there's that. Then you can see a lot of these are just adding the #include program.hpp. I think there's another one. Nope. If I say status, I know that, so we looked in source and include, and then there's a lot of stuff in docs because we just changed stuff there. Oh my, there's going to be a lot. Bison, there we go. So there was a difference there. So git diff bison. And all that I did is, because I was no longer using namespace standard, I had to put it in the bison. And in bison, there's two areas. One that, well, might as well just show you. There's two areas to #include something. The first one is the code sections, and it says it will be included in the .hpp file. Well, I don't want it there. But then top will be at the top of the CPP file, but not the HPP. And that's where I added it just then. So now I'm going to git add bison source and include. Did I miss anything? Other than docs, I'm going to do that as a separate commit. This is all docs. Nope. Okay. -m, and what is this? Just say small refactor, removing cyclical include of program.hpp from astnode.hpp and remove namespace std from say, Corey, that's a really long message. That's okay. Yeah. All right. Now we'll just do the docs. That should be everything. Okay, that way I don't have to look at it while I'm doing other stuff. Git commit update docs with latest refactor changes. All right, easy enough. Now let's get into the reason that we're here. And in our test document, we've got this library use. We've got a use invocation, a use as where we like kind of, you know, go into it, but use as into the global namespace. And function f this. Not going to work. At least it's not going to pass, I mean. And I'm correct. It did not pass. Why? Because floor is seen as a variable at this point and not something in the global namespace. And that is the goal of today's, or this episode's goal. That's the goal of this episode. So how do we solve this? Well, you know what? Let's look at the source for the AST node compiled. That's not there. Okay. Function declaration? Yes. Function declaration. Why? Because, well, we'll see this. So when we're dumping it, blah, 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 that's fine. When we're compiling it, so, okay, and then there's the compile preprocess. Okay, so we've got this functions collected. What is functions collected being used for? Do we have it in our, so it's in the program. There, program. And functions collected. Names of functions that are declared in a previous or the current scope. And it's a vector of a set of strings. And I think okay. Sorry, I was reading these other things. For functions collected, why is it a vector of strings? Because I bet if we look at program, just trying to find the right window. There we go. If we edit the source of program.cpp, push environment, we've got identifier stack, a string stack, and then all the functions collected, we push back a copy of the most recent one. So functions collected, just looking at other places that it appears. So this is in the push environment. This is in the pop, and all that we do is remove. Okay, functions collected. push. Okay, functions collected. That's all. Where else is this used? Functions collected. Okay. This is in the push. This is in the pop. Functions declaration. This is where we insert something into it. And then function declaration.cpp, line 64. What are we doing? That's the only one I don't know. Okay. Vim ast node function declaration line 64. Okay. This is in the compile of the function declaration. Okay, so what are we doing? We're reserving stack positions for any variable in the body that is not in the arguments. That's fine. Add an entry for each identifier. If the identifier is a function name, then leave enough room in the bytecode. What does that mean? In this particular case, I don't remember. That's why you write better comments. At least I have comments here. My phone is not on silent. I will put it on silent. It was on vibrate, just not on silent. All right. Add an entry for each identifier. Well, what are we doing? Okay, we're going through the arguments. Oh, okay, okay. So we're going through each of the arguments. Arguments.size. No, so that's we're skipping past the arguments. And while I is less than identifiers dot size plus plus I. Functions collected dot back. Okay, that's the functions collected again is this idea of it's a set of function names, and we're counting the identifiers, blah, blah, blah. I mean, counting, we're saying basically is the identifier sub I. So each of these identifiers, what are the identifiers? Let's, it's a vector of strings. Oh, okay, yeah. This is reserving the size. I'm like, what is it doing here? Duh. Oh, it would be nice if I just scrolled up. So we've got to reserve stack positions for any variable in the body that is not in the arguments. So the point of this is to get the right order. So identifiers, we reserve however many identifiers we need, because get identifiers is a set. And then we go through each of the identifiers, and I say it's a set, it's a vector. Yeah, and if it's less than identifiers at size, then we, okay. And an entry for each identifier. So the problem is, or what I'm thinking is, I'm wanting to co-opt this functions collected because that's the function names that need to propagate. I want it to be a functions are propagated and so are libraries. But I don't think that's going to work here. So program.get bytecode size, add the bytecode for opcode function, and then that's what it's saving to. Why? Because will need to be populated later once the function details are known. So what's happening here is this is when we're compiling what? A function declaration. So the way a function declaration works is that we, this is in the code, right? And then we, imagine the bytecode is being executed, and the very first thing it gets to is jump past the function, and then we get a new environment. Ensure we're setting, all of this is setting up the bytes for the bytecode, for the function that's being compiled. And so we probably will need to add to this, add an entry for each identifier. And then the string literals that need to be on the stack. And what happens is in this push environment, so program push environment, if we look at source, we're already in source, program.cpp, and then push environment. What does this do? We get a new set of identifiers, a new set of strings, a new set of functions, but we forward all of the previous collected functions. The break stack and continue stack, remember these are for if we have a break, we don't know where the break is happening. I mean, if we have a break in code, we don't know where it should jump to yet. So it gets put into this break stack so that when we pop that environment, we know where we can go back and set all of those break locations. Same way with the continue. Identifier assigned stack. So this is the list of identifiers that are have an assignment. Why? Because this allows us to pass something in by, dare I say, by reference as opposed to passing in by value. Making a copy or not is what it is. Okay, and then we run the pre-process on this, which not on this, but on the AST. So we push an environment, but we're pushing an environment for a specific AST. So we run compile preprocess on that. Yeah. So what I think we're going to need to do is so in the program, include program.hpp, we need to add some stuff. So we've got our stacks here. We've got a pointer to a... Okay, there. The identifier stack. Stack of sets of identifiers that are the target of an assignment statement within the associated scope. Okay. Strings, okay. Break and continue. So what I think is, just like we have the identifier stack, we need a stack of library aliases. That are used in the program. Okay. And that's going to be a vector of set of strings, and they are, we'll just call this library. Should we call it alias stack? Library alias stack. It's better to use more words than less. All right, so functions declared, functions collected. Just like we've got the get identifier, add identifier, get identifier, I think we need to add library alias and yeah. There we go. Add a library alias to the environment. Do I need the position? What happens if they use that the alias as a variable name, as an argument? The argument should take precedence. I'm going to leave the position for the moment. Okay? Add library alias. Okay. So we need to copy add identifier and get identifiers. All right. Add library alias. Get library aliases. I don't think I have a library alias stack, or do I? So I am there. Okay. Library alias stack. I'll still have to, on the add library alias, we'll say period, comma, period, plus 16, and we're going to substitute identifier with library alias there. And now let's fix stuff like library alias says library alias stack back. There. Okay. If the library alias's count of the name is equal to 0, then I'm going to put it there. Okay, all of this should just compile. We hope. So far, so good. All right. So we've got a spot to store them. Now, if we edit the, I'm already in source. So if we edit the include for AST node use, Oh no. Well, okay, fine. But it should have been the source for AST node use. And now we're adding an identifier, but maybe we shouldn't add an identifier. Maybe this should be library alias. All right. Why? Because now things are going to fail. Segmentation fault. Good. Well, good as in I know why. Okay. So push environment. Previous let's +7 substitute functions collected and instead have it be library aliases. Is a library, well, we'll do that. And let's look at program.hpp. Oh, so, okay. So for copying the functions collected, where are those? There. So the problem is, so what was I looking for? This, okay, undo, functions collected. This is a vector of a set of strings. Why aren't they behind an accessor thing and made private? I don't know. Probably just didn't think about it at the time. But so I'm going to undo that change, redo it. Library alias stack. Make a copy. Okay, simple as that. So for the pop, we store the okay, again, nothing, we haven't changed the way anything works. We're just adding scaffolding. Okay, so there is no map at. And it might be because here do we need both? This will make the things not crash anymore. The test still won't pass because we're not forwarding it into. But now the question is, how do we go about? Okay. So we're no longer crashing. And I'm not sure that we need to do this. All right. So when we go into a function, and we're going to compile it. So that's what this is. The whole point of this is that we are compiling a function, and as part of that, we need to move things onto the stack So reserve stack positions for any variable in the body that is not in the arguments. So the problem here is, or what it's solving, is it's saying if you are in a function and it has arguments A, B, and C, A, B, and C will be passed in, okay? And when you refer to A, it should go to that one. It should go to the spot of the stack, the very first one. B should be the second spot in the stack. C should be the third one. And then if you have a variable D, well, it's not going to be passed in. And so you need to reserve a spot. So what this is saying is for each of the identifiers, we want to we're going through it, and if, first of all, what is identifiers? Oh, it's a vector of strings. But get identifiers. What is program.get identifiers? I don't remember. Program.get identifiers. There. It returns a map And each entry is a string and then a size. And that's a position, I'm pretty sure. If its position is less than identifiers. What is identifiers? Yeah, I know that's what we're doing. We're getting it in the correct order. It would be not. You know, it's C++. You have structured bindings. What is the... I just want to see the tuples. Yeah, I'm not going to use the tie. Auto, and can I auto ampersand? Yeah. That should not cause any problems. Everything should still pass with the exception of the last one. Good. And that just lets us see what it's doing. Add an entry for each identifier. If the identifier is a function name, then leave room enough in the bytecode for the function name. Have we already called the push environment? Yes, so we've already prepared, so we know push environment will collect all of the expected variable names, strings, literals, function declarations, and library aliases. Okay, there we go. Add an entry for each identifier. So now we're starting at the past all the arguments. So for each identifier.size, so we're skipping everything. If it's in functions collected, then, okay, it's a function. Else, if program.get library get library aliases dot count sub I. This is a library alias. How can I copy an alias that already exists? I mean, I could just call peak, right? But I have to know where I'm peaking. So I may have to use the exact same technique that I used on the function stack declarations. I don't know where they are yet, and so it's at the end. But no, that won't get me past this, because the library aliases just for the moment, so this will compile. What I'm wondering is, in program dot, yeah. So for the functions, so we've got functions declared, and we know I know this is not the most riveting thing. The problem is we've got to figure out how to get the, let me just show you. So at the bottom, we've got use math.floor as floor. Okay? Now, at this point, floor is just a variable, but it's a special variable. And it is a variable that when we call the function, it needs to be passed in under the name floor. So I think that's, maybe that's what it is. When we're calling a function, no. I was like, can we automatically just put it on the stack? No, because we check for the number of arguments that are put on the stack, and it's got to match the number of declarations. But when we're calling f, here, 3.5, f could have been assigned something else. We don't know. We don't know if if it's a native function. We just don't know at that point. But wait, we do. So if I look at program-execute, call func. There we go. I'm trying to do tab completion and that doesn't work. If it is a compiled function, we could always just forward them when we're executing the compiled function, we just expect. Can we do it that way? That we just expect that the we just go. Okay, so what I was going to say is that part of calling a function, first we say, okay, what all arguments, and is it the right number? If yes, then we say, okay, well, this is the PC we're going to come back to. This is the frame pointer that we're going to come back to. And we set a new PC and frame pointer. But we could I'm just wanting to everything that's been pushed on, all of the libraries, all the aliases, to just automatically forward them after the arguments. Now that'd be after the arguments, before the strings. Yeah, I think that's the solution. So right here, it should be how do we know where they are? Is that a good solution? I'm thinking no. So what do I want to do? How do we want to solve this? You're saying, Corey, we've been staring at this for like an hour. I know. I told you I don't have a plan for this. I know what we want to solve. I just don't know how we're going to solve it. I think I like the idea of pushing them onto the stack. But see, the problem is we don't know let's go back to the test document. I want to see something for a moment. So when we're doing functions, that's shortcodes, template, native functions, trusted strings, multi-line comment, single line comment, class functions, pass by value versus ref, function call, recursion, that's what I'm looking for. Okay, print in times, and there was an inner, and did that get passed into? Yes. And then didn't we have a really weird one? I was thinking a function within a function, and did the parent one get passed through? Okay. So during program execution, here's what we're going to do. We were trying to handle it during compiling. Although that's still, I think, the right choice. So get library aliases. I'm sorry, I'm having to look again, because I've gone like through 3 different things. that are used in the program. Now this is during that are used in the program. Okay, so I'm going to change this up a little bit. First of all, I'm going to go back. The library alias stack is going to be a vector of sets of strings. I'm not going to do this size thing. Okay, and add library alias and forget the position thing because it's a set. Okay. Get library aliases is going to return a map of, no it's not, it's going to a set of strings. And I forgot my closing. There we go. Now what do we do with this information? Well, we need to go to the add because that's not going to compile. So that's program.cpp, that's buffer2. Add library alias. Alias stack back, that's fine. Is it .insert for a C++ set? I don't remember. It is insert. There. We just insert it. You know what? We should probably just do there. All right. So now we've got our alias stack. Now when we're executing, however, that is more interesting. So for this, because when we're, oh wait. Sorry, I'm thinking as usual. In other words, what I'm wanting to do is when we're executing full story, we load a library when we get to the point of saving it. Or rather, when we go into a new context. Let me just open up the test file. So in short, when we get to here, when we say use math.floor as floor, when we say as floor, then the identifier floor, wherever that is, we need to, it's a computed expression. That, in short, that's what it is. It's a computed expression, and all that we need to do then is, when we're creating the next context is to pull out the, if it was a computed expression in the current, excuse me. No, we should just pull them all out. But what if it's not using the immediate one? What if it's using a secondary one? Do we save the name of the functions, the name of the variables? And the answer is no, we don't. Should we? Interesting thought. No, because how do we know that it is? It's an identifier. We save the names of the identifiers. Okay. And we've got the library alias. It's a stack of library aliases. So we've got these as names, and we've got our identifiers and where they are in the stack. So we should be able to, of our identifiers, go ahead and push in all the aliases. Okay, but the thing is we've got to have a place to put them, and we have to know how to retrieve them. We know half of it at compile time, we know the other half at runtime. We don't know the correlation between the two. Then for the use, what does its compiling look like? We add the alias to the, we say, hey, there's a library alias there, and we're using it as an identifier. And when we compile our function, oh, wait. When we call push environment, it creates a copy when we call push environment, it says everything that was in the aliases, add them, and this is going to be a collection of strings. Okay. So what I'm thinking of, is there another structure that we need? Just like we've got a structure for the frame pointers, a structure for the program counters, a structure for the libraries that we can load out of. The problem is when we're loading that's it, kind of. Sorry, brain just kicked into gear. When we're compiling, so for any variable in the body that is not in the arguments, get a vector of stack names. Okay, that's fine. So if this is in the set of library aliases, the question is have we already what I'm trying to say is, have we already I know, just stop talking. I do that sometimes. We can't refer to it as a string because we have not put the string literals on the stack yet. That happens in the next section. We could refer to them by number if we knew a number to associate with them. I know I'm thinking about this really, really, really hard. every way that because I've thought about 5 different ways while I've been sitting here, and all of them are hacky. They're ugly. I don't like the solutions. So what do we know at compile time? At compile time, we can know as we're going into a function, we know what are the library aliases. The simple answer is to say, well, they don't propagate. You just have to call them again. But that's ugly. We know what the library aliases are, but we don't have them. We do call a compile on them. No, the current way I'm thinking of them is putting them on the stack. And again, I don't like that solution. Basically, I kind of want them waiting in the wings. And that's the idea of as we're compiling it, just like we've got the frame pointer, a stack of frame pointers and a stack of this other, it's like, well, now we need a stack of garbage collected values that are the libraries. And so when we're compiling and we're saving a spot, right now we're doing an opcode null val, and what we really need is a library load and an index. So if we look at the include for opcode, we've got a library, which we pop a name, push a library by that, but we could have lib copy. Lib copy. Load from library. What do I do with the so I'll just call those like, yeah. I think that's the answer. Yeah, library copy. Okay, this is ugly. Edit this source. We're already in source. Program dump. So after library, we need an opcode library copy. Library copy. And this will be PC plus 1, and then plus equals 2. And edit, or do we have program execute? Yes, we do. Just one. Auto. Not argc. I was looking at the bottom. So now it doesn't do anything but push back. But we don't know where yet. So we need this information. So every time we have a using, that is what yeah, every time we have a using, that is a case for saving a new item. Oh, I'm saying library load. It is library copy. This is just getting it so that it will compile. And I don't have a clear idea yet in my mind of what I want this to look like. That's kind of the problem here. And so I've got this library copy that, you know what, since I've added an opcode, I'm going to go ahead and on the right hand side make clean and now just redo the build. Do I need an opcode for library save? I think I do. Because that would be I think I do. Okay. This is not popping. This is get index. Get index. Save to notice we're not popping. Okay. We need to add the opcode for that in the dump. Library save. And the same way on the execute. Library save. We don't push back anything. We just move on. Okay, I think that's all the opcodes. All right, let it do its thing, which, again, nothing's working, but I don't care now. I have an idea. That is, I have a plan. So, as part of the execution, hey, we're in the program execute right now. We go to the top, and we've got program counter, frame, execution stack. So right here, we're going to use to propagate See, now it's making sense in my head. Once I figured out where I needed all the parts, it's like, oh, all this falls into place. Used to propagate loaded libraries into of not computed. Well, of compiled is that right? Compiled functions? During execution. Okay, and that is going to be a vector of, and then what is this? I'm really thinking that it needs to be a map of integer to garbage collected. You know what? Let's even say integer t to garbage collected. That's fine, and it will be called the library alias stack. All right. And it is empty. And now, every time so library loads that. Library save. That's a int t. Okay, that's fine. So we're just going to say library alias stack dot back insert index and whatever's on the top of the stack. Stack.back. Is it really this easy? Probably not, but right now I'm thinking it is. Okay, problem is it's empty at first, and it shouldn't be empty. It should have 1. Okay, so we'll do that in just a moment. Now for this one, stack.pushback. We're going to say auto ampersand aliases is equal to alias stack.back. .count index. If that's the case, then do something else. Do something else. And I should not have done that, but or that's a null. Stack.pushback aliases.at index. Okay, let's go back to the top because can I do that? See if it's gonna complain about the compiling. It didn't. Okay, great. So what does this mean? Library aliases stack starts off with nothing in it. Now we just need to propagate forward the so when we're compiling, for each one it needs to have a number that we can use here. That's the wan't. And when we load a library, just add library save and that number. So after we call the library, and that's going to be, I don't have it here, that's fine. Not source, we're already in there. AST node use before we poke it. Well, it doesn't matter. It could be after. Into the library, is it aliases? We're in number 5. Let's look at number 7. Alias stack. library save, and I'll worry about where in a moment. Okay. Now, we're close. When I'm compiling, so I add a library alias. Is that really what I want to do? I mean, yes, I do want to add a library alias, and I want that to just work. So what is add library alias doing? Well, let's look at that. Because it is a it's a set. It's no longer going to be a set. We are going to it's going to be a map of the name so auto ampersand current aliases is equal to there. And now current aliases insert, and that's going to be a pair of name and is it size or count? Size. Okay, so the goal is, or the intent is, it doesn't matter if we already had an entry in there. We want a new entry, right? Because if we're saying use something and calling it M, and then later on we say use something, call it M, we want it to use that one. Yes. So insert, okay, and it's not going to like this because current aliases is returning the wrong type now. So if we say get library aliases is no longer a set of strings, it should be a map of string, comma, you wanted your T? Can I use that? Sure. Let's edit the program.h. There we go. And this is a You integer t, and this is also going to be a vector. Oh, no, it's a map of string you integer t and add string, and it will automatically we still don't have it working in the compiling step. Compiling of our script, not meaning the compiling of the C++. Okay, so that's okay. I was expecting it to fail. So now what needs to happen? When we're compiling, now I need to, because I've done things in different parts, now I've got to kind of regroup and say, big picture, what should be happening? Basically, every time we see a use, so that's going to be in the use compile, ASC node use, that's B5. As part of the pre-process, add library alias. That's fine. When we're compiling it, it's going to be auto ampersand aliases is equal to program.get. Why can I not spell library? Type it. Library. I think it's aliases. I'm in 5. Yeah. Okay, so saving it, and I need an extra close. And where's test? I want to dump our bytecode here. P1 dot dump bytecode. Now we haven't done the load. That's the other thing. Okay. So, what's it doing? First of all, null val, null val. I'm guessing one is for floor, one's for F. Okay. And math and floor. Peek at 2. That's math, not Pikachu, peek at 2. Math, library. Peek 3, floor, period. Poke that into 0. Library save, 0. So that's library position 0. And then pop. Jump to 38. That's past the function. Function, one argument, and it starts at number 24. Okay? We poke. Now, okay. Now, this 24 null val, what does this represent? That's the word floor, because we don't know what to do with it. We're about to fix that. So, where would this be? Identifier. And I don't have that open yet. So, edit AST node identifier. And this is saying get identifiers. Oh, wait. Nope. It's not here either. It is in the set of functions that, it's in the function declaration. Yes. Back to our old friend here. And that's where it is. This is a library alias. Is equal to if alias dot count of what is identifiers? Identifiers is a vector of string, so it's a string. So identifier sub I is a string. Then do that. Else do that. And what is the this? Dot add bytecode library load and program add bytecode of at identifier sub I. Will that compile? No. Aliases. Library copy, not load. Maybe it should be load, but it's a copy. It says it passed. Okay, look at this. A couple things. We've got our library copy of 0. Yeah. Which was library and library save 0. You know what? Okay. Here's what we'll do. our test, E6. I'm really, really happy right now, by the way. I know that was a lot of work, but it's like once I had to think about it for about an hour, maybe an hour and a half. Once I did, it's like, oh, that's all it takes. So the library till the inner function is executed. And so what we'll have here is we will have a function f inner of y return f inner of x. Oh, and there's a dump bytecode. But it failed. No! Okay, first of all, got rid of that. Now, I think it's probably in the, when we call a, so let's see what our source code looks like. Null val, that's probably floor, and then F. Math floor, peak 2, that's math, library, peak 3, which is floor, period. Poke that into 0. That's save as floor. Library save 0. Okay, and then pop. Jump to 64. 64 is declare that as a function. Poke 1. Oh, that's saving it in F. Okay. Pop float 3.5, peak 1, that is our function f. Call func, and then print. Okay. So, 24, let's go up here. 1 and 29. One argument, 29. What's 29? Oh, it starts at 24. Oh, jump to 45. Why? Because we're declaring another function. So at 24, f inner is 129. Yes. Now we just jump to 45, which is, 129. Poke that into 1. Is that right? Peak 1, call func with 1, return popping 2. Yeah, I guess that's how it would read that. Okay, that's fine. But what's it doing inside here? Starts at 29, which is a null val. That's the x. Library copy 0. That should be floor. Should be. Peak 1, peak 2. So what would 1 be? Because I'm looking at the 1 should be X, or the Y. No. Should be floor. What's 2? Call func. So 2 would be the... Oh, okay. So we've got a null, we've got the library copy, that's a 1, and then what's in 2? Here's my question. Does this work? That is the problem with the function itself? What do I mean by that? If I don't do that, and I just have return X and return fenter, and then 3.5, do I get 3.5 out? No. So this may be a completely different problem. Because if fenter I think this is a completely wrong problem. So before I want to trace this. Maybe this is an unrelated problem, and maybe the other thing works perfectly now with all of our work. Seeing as how that's what I was trying to solve in the first place. So we've got a null val. That is for f, jump to 37. 37 says there's a function that takes one argument that starts at number 3. Okay, that's fine. Poke 0. Oh, yeah, we're saving it in F. Poke 0. Pop the result. Float 3.5. Peak 0. That's our function. Call function 1. So 3.5 is on the stack. We know that. 3.5 is on the stack. Why am I saying it twice? Because 3.5 is on the stack. Call function with 1. I'm telling it I'm giving it 1 argument. Okay. And this function says go to 3. So 3 puts function 1.18 on the stack. And then jump to 18. '18 says there's a function 1.8. Okay, wait, so first it puts function 1.8 on the stack. Now there's 2 things on the stack. And then I jump function 1.8. There's 3 things on the stack, the function twice. Poke that into 1, which was already function 1.8. And then pop it. So there's 2 things. Peak 0, which is 3.5. Peak 1, which is the function, call it. And what's the function? 1.8. Okay. So 1.8, go to 8. So wait, we're calling it with, we peaked 0, which is 3.5, peak 1, call it with 1. Okay. So 3.5 is on the stack for at 8. Null val. Oh, it should be return y. Maybe this is working correctly. No, it still failed. Okay. Still don't know why I'm getting function 1.8. Function 1.8, jump to 17. Function 1.8, poke that into 1 when it's already there. I mean, it's not necessarily harming anything, but it's just like, well, it's putting it on the, it's like it's reserving the spot and then it's executing it. Okay, interesting. Function 1.3. Peak 0, peak 1, call. Return popping 2. Oh, and it did. Okay, so that is actually working now. So the question is does it work? And I was just my bug in my test. If that's the case, I'll be mad. Because I wasted about 15 minutes on it. It's passing. And I'm mad! Even though I'm happy that it's passing. Can't believe that. Just a stupid bug. Alright. So, what does this tell us? This is cool. It means that we have math.floor as floor. We've got, it doesn't get used until an inner function, which means it is being properly propagated. We can even I was thinking about doing another test. In fact, I'm going to. Here, the library reference is not honored because it has the same name as an argument. Floor. And here it's just going to be 5, 1. I think that's the right number of zeros. That's what we expect to happen. no, it failed. F enter X, and we're using the word floor for that. Well, before I go on, let's do the dump bytecode. All right, so we've got a null val that will be floor and F, math floor, peak math, library, peak floor, do the period, poke that into 0, library save 0, pop. I know why. Well, wait. Well, I'll just keep going. Jump to 57. And that's function is 1 starting at 24. That's what we jumped over. Poke 1. Oh, yeah, we're saving it. That's F. We're saving it. Null val. Okay. 1. And pop is, yep, float 3.5. That's the 3.5. Peak 1, that's floor. No, that's F, sorry. Call it, and then print its result. Okay, so at 24, we go up here, and it says function 129. That is F enter. But, and then jump to 38. 38 is putting function 129, poking that into 1. Why? Because 0 is X. Pop peak 0, peak 1. So 0 is the value X, 3.5. Peak 1 is the function call it. And so that's going to 29. At 29, peak 0. That's the value that's passed in. Return. It's not calling a function. That looks correct. Now that would be a context. Is it just result? It's a null. Make sure I don't have a stupid mistake again. Now we can simplify this further. There we go. All right. Poke it into 0. That's floor. Library. Save. Okay. Pop. Jump to 33 because that is the function of 1 that starts at 24. Okay. Poke that into 1, which is the pop. Okay. Float 3.5, peak 1, that's our function. Call the function. Okay, so that starts at 24. Okay. 24, peak 0, which should be 3.5, return. That seems pretty straightforward to me. How is this failing? What am I getting wrong? Look, it's returning 3.5. Null val. Oh, no. That's the 00 null val. I didn't put an end line. Okay. Just to show you. At this point, I feel like there's probably a stupid mistake. Those happen. And again, just but why? It's not printing it. I'm looking at the wrong one. So this right here is working. So the 2289 that's failing is this one right here. This one passed. If I uncomment that, does it fail? No, it passed. Wait, so that worked. Floor was returned. So that one's working. This one is failing. Well, that wouldn't have made any sense whatsoever. Try this again. Okay. So use math.floor as floor. Function f of x, enter, or floor, where you just return floor. Call enter with x, fenter with x, and call that. Now, here's a question. If we comment that out, does it work? It may have worked a moment ago. It's working. I'm just making stupid mistakes when doing it. Okay, I'm leaving those tests though. They're worth it. Or that is, they're testing something that's worth testing. So, what all do we have? Global namespace. Global namespace. That's fine. Are there any other tests we need to do? I don't think so. I think we've got a good set. So what all are we testing? Simple use as, putting it into global namespace. Yep. All right. library save, library copy. AST node use compile preprocess. Or compile. There we go. Did not need to there. Now, what did we do? Like, I have no idea. How do we describe this? Well, we added library aliases to a global namespace for use in namespace so that they are propagated to compiled function calls. Everything's still passing on this right-hand side. That's right there. That's good. Update our docs. Will be significant. All of this, you know, you get add docs. Update docs for episode, anybody know? 74. Okay, we're caught up. Pushing it all up there. These pushes get bigger and bigger. Zero 074 0. Anything that we can... Nope. Okay. Oh, Vim. Git tag, git push, origin episode 074. And whew, that was a big one. Oh, where does this put us? 10,366 and 3,400 lines of comments. Yay. Well, so we lost a little over an hour to trying to figure out different ways of solving this. We finally did solve it by deciding that we needed to keep all of the libraries when we're executing and we call a user-defined function, a compiled function, we need to store those libraries, and we can reference them by an index number. And when we are compiling them, likewise, we can sorry, no, I just kind of stopped to think. Likewise, when we compile them, we can keep track of what index number they will have. And so we had to add a few new opcodes for storing, copying the library and then loading it back out. But in the end, and why did we do it that way? Because what if, heaven forbid, somebody inside their function maybe loads a library and uses the same alias? Should they be able to do that? I would think so. So our current structure will allow that. Maybe we should have written a test for it, but it will allow it. Is there anything else? Well, I mean, there's a lot of stuff we can do still. It's worth pulling up the... there, I'll put it back. What all do we have left to do? I would kind of like to just sort of switch gears entirely and maybe focus on our location tracking. Right now we haven't done anything with it, and we've got a lot of those AST nodes, and I mean, and each one of them are, we're not really doing the tracking of our locations right, I don't think. We could focus on the math library as well. Our execution count, so that we can stop our execution at certain points. In fact, we don't even have it, but we could. But where we halt execution when there's an error, we could do that. We haven't looked at optimization at all, and in fact, there's kind of one that I just saw, about the double declaring a function, and that's unnecessary. So, I'll think about that. Yeah. All right, so what else? What's coming up next then? I think I want to start looking at either the location tracking or the percent encoding and decoding, but I don't want to go back into strings yet. But we might. And then there's a few other things on optimization, dealing with the string view instead of strings themselves, and just different things we can do there. Yeah. I'm okay with all this. I mean, I think we've done a good job. Let's, for the time being then, excuse me, had a yawn. Let's call it a night. We are approaching the 3-hour point. This is my second video today. Why? Because right now it's Christmas. Well, it's past midnight on Christmas Eve, so it's Christmas morning. And I think I'm going to go to sleep. But you know what? Again, as always, I hope that this has been of benefit to you in some way, even if we did have to stare at the code for about an hour. So my apologies for that, but that's the way that development happens sometimes. But as always, thank you for joining me. Have a great day. Have a Merry Christmas. And bye.